Superman so powerful, huh?
Wow, so handsome.
Guys, I think I also want to become like Superman lah. I also want to fly in the sky.
Wow, seriously?
Jom guys, I will show you guys how I fly. Jom.
Okay, let's go.
A few moments later.
Dior, the new eau de parfum, Dior.
Hi guys! We may see me in movies for superheroes to fly with a red cape, but obviously with Guan Cheng's experience, a red cape does no job on him. So, what may help him to fly? In the scientific world, we have something called de Bernoulli's principle, which states that an increased velocity of fluid, be it gas or liquid, it exerts low pressure. Sounds confusing, huh? Well, fret not, because I'm here today to show you guys some interesting experiments for you to understand what is Bernoulli's principle. One easy example that we can observe Bernoulli's principle is by blowing the space in between two balloons. When the air space is blown, it creates a high velocity airflow, which causes a low pressure area in the space in between. And the air surrounding the balloons that has a higher pressure than the space in between exerts a force that pushes the two balloons together. Alright, the balloons are down. Now let's get into some magic. You see that ping pong ball? We're going to make it float. Don't believe it? Let's watch. Alright, the theory behind the floating ping pong ball can be explained by de Bernoulli's principle. The blow dryer increases the velocity of airflow surrounding the ping pong ball and lowers the air pressure. And the air outside of the blow dryer airstream possesses a relatively slow airflow rate and exerts a greater force on the ping pong ball, which causes the ping pong ball to stay within the column of low pressure air. Alright, now let's move to the next one. You see this container filled with polystyrene foams. We're trying to take all of these out from the container through this tall paper column. Again, we need our mighty helper, the blow dryer, to be placed at the mouth of this tall column and turn it on. See? All of the polystyrene foams are flying out. According to Bernoulli's principle, the air from the blow dryer increases the airflow rate at the mouth of the paper column, which this creates a low pressure region throughout the column space. And the atmospheric air pressure that's exerted surrounding the paper column is actually higher than that in the column space. Henceforth, the created pressure forced all these polystyrene films to enter into the column and pushed out of the column. Now, could you relate Bernoulli's principle with daily life applications? Well, if you could recall, the beautiful lady that used perfume in the previous scene has actually applied the Bernoulli's principle. With a pump and squeeze, the air is rushing through the tube and creates a low pressure in the tube. The high pressure in the bottle forces the perfume liquid to draw up into the low pressure airstream tube and squirt the perfume out as fine particles into the atmosphere. The same principle applies to birds flying in the air. They fly because of the aerodynamic wing structure that causes air to move more quickly over the longer surface of the upper wing than the shorter surface on the underside of the wing. This difference in airflow velocity between the wing surfaces creates lower air pressure on top and high pressure below, which this generates the lift that raises the bird's wings and assists the birds to fly.
Birds can fly. They have wings. Maybe I need some wings.
Okay, it's time to fly.